So, hello everyone again, Nasrin Olson here. The next session is titled Haptograms as an adaptation of social haptic communication, user participation in the design process. There will be 4 of us presenting that session. I just want to mention that we were meant to conduct a lot of participatory experiments with social haptic communication and converting them to haptograms. But we actually had booked a lot of meetings, workshops that every one of us was supposed to go there with all of the equipments and meeting people. But of course, COVID happened and put a stop to all of that. So you will see a little bit of what we managed to do in the times of COVID. So the next presentation starts now.
Good afternoon, ladies and gentlemen. My name is Sándor Darányi from the Swedish School of Library and Information Science at the University of Borås. This joint presentation by Nasrin Olson, Rita Lahtinen, Russ Palmer and myself, entitled Haptograms as an adaptation of social haptic communication, user participation in the design process, will have 3 parts. In the first section, you will learn about haptograms. In the second, social haptic communication will be discussed. In the final section, a new tool will be introduced to support easy haptogram design, both in the SUITCEYES project and beyond. There are well-known ways to transfer semantic content for users with or without deafblindness. They include braille, top left, haptic signals, bottom left, pictograms, top right, and logograms, bottom right. The latter type, logograms, represent concepts, and we took inspiration from them when we decided to design a vocabulary of haptograms for the project. Haptograms stand for tangible ideas. Their shapes refer to the encoded concepts and the respective activation sequences by a set of actuators to the dynamics of their unfolding. This is a new approach to two-way communication for people with deafblindness. To conceive it, we had to integrate linguistic theory with technical feasibility. At the same time, special limitations were set by demands on smart textiles, hardened software, psychophysics-based pattern recognition, and conceptualization for semantic reasoning. The purpose of haptograms in our framework was to implement an ontology-dependent messaging language for situation awareness information leading to simple conversation. A haptogram is a tactile symbol drawn over a touchscreen, its dynamic nature referring to the act of writing or drawing, where the touchscreen can take several forms, including a smart textile garment designated for specific areas on the body. We used vibrotactile actuators to display haptograms in a matrix of rows and columns, that is, an M times N arrangement where M and N are not necessarily equal numbers. SUITCEYES prototypes that use haptograms are the Haptic Quest, the Chairable, and the multi-panel suite. We will see the multi-panel suite and the Vest in more detail. The Chairable is a seat covered with smart textile, which relays messages to the user's back. The current haptogram vocabulary has 155 concepts, enabling sentence construction as well as single-word messages. To the left, we see an experimental multi-panel haptic suite. Smart textile covers the back, the shoulders, the arms, the waist, the thighs, and the lower legs. All these areas can be used to display haptograms, although their sensitivity and respective sign perception is different. To the right, we can see 2 printed circuit boards, one with 32 the other with 40 channels, and the way they can be connected to design and perceive more or larger haptograms. This slide shows the current Haptic Quest covering the torso, with 16 actuators placed in a 4x4 grid on its back, 2 actuators on the right and left shoulders, respectively, and 5 placed in the belt area. The actuators are the yellow patches in the figure. The blue and green patches correspond to the hardware. Different actuators in different body zones can receive certain kinds of messages. For example, the shoulder zone can distinguish between yes or no. A screen on the back displays haptograms corresponding to concepts and relations, plus haptogram sequences for sentences, including system messages. The waist area can encode different topics to frame concepts, called contextualization. By the Haptic Quest, we can simulate two-way communication between the user and the haptic intelligent personalized interface. The user sends a pre-coded question to the interface by the input device called the tactile board, such as "Where am I?" In turn, the interface states, "You are in the kitchen." It can also inform the user about more complicated questions, for example, when and where an object was detected. By means of haptograms, the answer arrives on the body as a display. With more actuators organized in grids over multiple body parts with different sensitivities, more complex answers will become possible in the future. The answer comes from the visual analysis and situational awareness component of the haptic intelligent personalized interface, which detects objects in the environment and labels or names them by the ontology. Such an answer is encoded into a sequence of haptograms with syntactic and semantic rules to form a sentence. We adopted distributional semantics for our solution and used it for the double contextualization of semantic content. In distributional semantics, the meaning of a word depends on its context. For example, riverbank is different from bank as a financial institution. We distinguished between content words such as you, chair, mobile, then topics such as kitchen, elevator, living room, dining room, and so on, and contexts. There are 6 contexts: space, time, person, emotion, activity, and range. Double contextualization means the framing of content words by topics, and in turn, topics by their contexts. The result is a simple haptic language with repetitive elements to help learnability. To recognize incoming semantic content, the user has to remember 2 simple rules. Rule number 1 is that haptograms are node activation sequences in a matrix of actuators. This is shown in the upper figure, where the orange path, progressing basically from the bottom to the top, corresponds to the sequence of switching actuators on and off. Such a pattern stands for a concept, for example, for mobile. The second rule is that sentences are haptogram sequences. To the right, we can see 2 incoming haptograms, one after the other, with 2 different actuator activation sequences. Here the sentence would be, for example, here is the mobile. Practically, here, mobile. Let us look at a real example. The answer, a sentence to be sent to the back of the Haptic Quest, is, "You are in the kitchen." In the lower part of the slide, you can see a series of haptic patterns, indicated in red, with their respective node actuation sequences to their left, in white. To help their learnability, we differentiate between syntactic haptograms to help sentence construction and semantic ones with conceptual content. Syntactic haptograms are repetitive, so that they can be reused for the construction of new sentences based on the same rules. Given the current abilities of the haptic intelligent personalized interface, one such rule was to frame concepts by topics to distinguish between a kitchen window and a bathroom window, for example. The second important rule was to embed such concepts, framed by topics, in one of 6 contexts, that is, space, time, person, emotion, activity, and range. This is what we call double contextualization. Thus, we can express the difference between a person by the kitchen window and an activity by the kitchen window. In the middle of the figure, you can follow the sequence and types of incoming haptograms which encode the above message. In red, system messages start and end the sentence. In green, the user receives warnings that a context or a topic is about to start or finish. In blue, concepts representing contexts and topics appear one by one. The current haptogram vocabulary is limited to an indoor environment. We worked with a worst-case scenario, that is, complete dual sensory loss of the user, as our starting point, where every element of communication must be predefined because none will be supported or replaced by visual or audible information. Haptograms for the haptic intelligent personalized interface were encoded as complexes of parameterized physical constituents, also known as haptemes. These will be discussed in more detail by Rita and Russ, our next presenters. Based on psychophysical experiments, static patterns on the back were discarded in favor of dynamic haptograms, as these are better perceived by the users. And finally, about lessons learned. To pave the way for the participatory co-design of haptograms, we learned important lessons. These included the following. In real life, social haptic communication uses lots of sophisticated gestures over multiple body parts. It is not possible to copy these to a single 4x4 display on the back, hence the need for a garment with several displays of several sizes. More sensitive body areas allow for larger actuator grids as displays, subject to experimental results by psychophysics. The more actuators in a grid, the more kinds of haptograms can be designed, meaning that the vocabulary and the set of pre-coded questions will expand. Bigger vocabularies with more complex messages will present learning problems of their own, so the role of tutoring and learning communities, also in a classroom setting, will be important. Now it's my pleasure to pass on the word to Rita and Russ.
I'm Rita Lahtinen and I'm from Finland.
And I'm Russ Palmer and I'm from England.
And your sign name is?
My sign name is Russ. Like that.
Yeah. So when we met early 1990 in Sweden, we started to think that how we as a couple can use touch messages. And still now, after 30 years living together, I've been doing this communication research work on social haptic communication. I did my thesis on this haptices and haptemes 2008. So what are haptices? So these haptices are touch messages between 2 or more people in a social setting. And haptemes are the grammar elements of our touch, which include, for example, location, pressure, duration, size, movements, and haptic distance. All haptices, they share the multidimensional meanings and emotions.
Now, being deaf-blind with 2 cochlear implants, I use spoken language. So I find the social haptic communication part of the social haptic philosophy is the vital part of my life. Without it, I'm totally lost. Why is that? Because it gives me real-time information. It tells me what's going on in the environment, and it also gives me people's body language, because I can't see anything at all. My vision is totally zero. I can't read text and I can't see people's faces. So I have to rely on social haptics to give me this information.
This slide, we have a picture of big cross emergency haptics made on the back. I'm just doing that on the arm now here. So this haptics emergency, its grammar elements, haptemes, consist of the location, here on the picture made on the back, pressure, so Russ, you need to feel that, so it have to be normal or like heavy, yeah. Also the direction of movements, that has agreed that it's the shape of letter X, what you can recognize. Speed and duration, it have to be recognizable. So if I do it too quick, you probably don't recognize it. Size, it needs to be big enough you to know that emergency. Hand shape, I can do like 2 fingers or the side of my hand so that you can actually feel that, and it's not too painful. If I do it very quickly on my top of my finger, it can be too painful. The body posture and orientation is free. So it means that if you are on the bed or if you are standing, I can always use this emergency haptics wherever on your body.
Now, sometimes when I have different interpreters, they have different ways of touch. Some are very light, some are very heavy in the way they give me the information. So you have to be very consistent. And also when the person gives you the information, they need to keep the contact all the time. If the pressure's too light, it can be very ticklish. And if the pressure's too heavy, it can be quite hurtful. And like Rita says, if you do it in a very sort of digging way, that's not so nice compared to doing with the side of a hand. So it does depend on the situation and where you give the information. It can either be done either on the back, on the side of a shoulder, or even on the side of a leg, on the outer side. So it's very universal. It can be moved to different locations.
So how do we use haptics, or what they are made of? People are usually asking me. So haptics are usually adapted from from your body movements. If I like to change my location to the other side, that's for example. Or the orientation was what you are now like standing or sitting, and then you are touching something in front of you. So I can then describe that for you. Sometimes they are made of what functional activities you are doing. So if you are like pouring a drink, so I can say it's filled up, or you need a little bit more water. It can be made of a written language. For example, letter T. That's letter over here, and then here or on the back. Or it can be made of sign language. For example, Finnish sign for coffee. I have adapted that to perhaps a shoulder, and that is coffee. Sometimes they can be made of visual drawing system. Like if I draw perhaps the room and the door, so I can also draw the same kind of way what I see as a visual image. And that is belong to the mapping of the environment. Sometimes they can be made of sound and vibrations. For example, if I'm describing musical elements, so this was high pitch and this is low.
Now, there's different aspects to this, and how the information received is very important. As Rita just demonstrated, some of the information can be variable, and also for different locations, different sort of environmental considerations. One of the most important things about this is that it can be used for different groups. It can either be used for a deaf-blind group. Now, the deaf-blind group is quite a big group. You have the spoken language users, you have sign language users, and you have the congenitally deaf-blind users. So the social haptic can be adapted according to each group. In addition, over the years, we found that the visually impaired people, blind people who have hearing, also find it useful for environmental description. And furthermore, some of the learning disability, autistic, and even people with communication disorders can also be used in terminally ill health settings, and also if people are having intensive care, if they need communication. So it's a very widely adaptable system.
Now it's my turn, Nasrin, to talk about our co-design efforts. Initially, our haptogram design work was planned to involve participatory co-design workshops with potential users. Of course, COVID put a stop to that, so we ended up being only 4 people trying to collaborate from distance. I was situated here in Sweden, my colleague Shando was in Hungary, and Rita and Ras were in lockdown in the UK. We used Zoom to communicate. Rita and Ras showed us their way of conveying different messages using social haptic communication. The meetings were recorded, and I also made some notes and sketches based on what Rita and Ras showed us. This image shows my sketch for the haptics room. 2 fingers of each hand start from the top middle of the back and then move in opposite direction, then downwards to draw a square. At the end, the right hand shows the position for the door. Once we had the patterns for different haptices, we could then discuss how to best create a haptogram that would be recognizable by someone who knows social haptic communication. We also needed to consider the different grid sizes, which at the time were 4x4 and 5x5 and only for the back. We could not test the haptograms, of course, with users from distance, but we discussed the patterns that we had designed with Rita and Ras and modified them if needed based on their feedback. We also had to consider the results of psychophysics experiments conducted by our colleagues. For example, based on the results, we experimented with drawing a room by activating the actuators only in one direction. So we started from the bottom, then up, then right, and down again. A haptogram is basically the pattern that is created when a series of nodes or actuators are activated in a certain order. This means that every haptogram requires activation of multiple actuators. And the way to instruct each actuator to vibrate is to write a piece of code. I'm showing an example of instructions for the haptogram room. What I'm showing basically is 19 lines which all start by frame duration is equal to, then mostly zeros, commas, and numbers. As you can imagine, to write this type of instructions can be time-consuming, tedious, and also prone to error. So we decided to design an app that would facilitate this task, both for us and also others who may need to write similar codes in other settings. I now demonstrate how this app works. We can add a new haptogram simply by choosing the option Add. I can, for example, try to create a haptogram for emergency, as was mentioned earlier by Rita. The app provides a visualization of a 5x5 grid as shown. That is, there are 25 red circles arranged in 5 rows and 5 columns. I can then simply use the mouse to draw a cross from top left to bottom right, and then from top right to bottom left. Moving the mouse in the way we choose automatically creates the instruction to activate the actuators in the exact order that I indicate by the mouse. To make sure that this is actually the case, one can choose between 2 options, run or simulate. Pressing run will activate the actuators, which you cannot, of course, see. So instead, I press simulate to show you in which order the actuators have been programmed to get activated. As shown, a cross is drawn by a sequence of nodes being turned on one after another. We call each of these activation steps or components of a haptogram a frame. Looking back, we might decide that the timing of activation is just too fast. That's not a problem. With this app, we can have different options to simply customize the shape and the flow of the haptograms exactly as we want. We can set the timing by altering the duration. I have created the same emergency haptogram, this time to run more slowly. The intensity of vibration can also be varied from very low to 255, which is the maximum intensity. So if we want to have the first and the last of the nodes, or in fact any of the other nodes in the haptogram to vibrate more intensively or less intensively, that is easily possible. We can instruct the actuators to be activated in a sequence one after another, or by pressing Shift while drawing with the mouse, we can activate multiple actuators all together in one frame. If we decide to modify a haptogram by adding a new frame in it, that's also fine. We can just add a new frame like this. Similarly, we can also delete frames if something is not exactly as we want. In this way, we can create very sophisticated haptograms with complicated patterns. As well as adding or deleting frames, we can of course add or delete a haptogram fully too. When we create a new haptogram, the label for it appears on top of the list of the haptograms. But as the list starts getting longer and longer, as we create more and more haptograms, we might choose to sort the haptograms in different orders to help us locate them more easily. One can draw many shapes just by using a 5x5 grid, by varying the order, the intensity, pattern of activation, number of nodes used in each frame, or the number of frames in each haptogram. But although theoretically one can use just the 5x5 grid to create unlimited haptograms, some of these haptograms will become so similar to one another or so complicated that it would be too difficult for us, for our body, to distinguish between them or learn what they mean. But if we go for simpler designs and involve different body parts, it becomes easier for the user to both distinguish between the incoming messages and also to learn what they may mean. For example, if we know that any message received around the waist is related to direction, or messages received on upper left arm are about emotion, then it becomes easier to distinguish between them and also, given time, learn what they may mean. So how does this app can help us design such haptograms that require sending vibrotactile stimuli to different body parts? A 5x5 grid does not make it easy. Well, that's not a problem either, because this app allows various grid sizes. We can choose which is most relevant for us for each haptogram. If we, for example, want to have a 5x5 grid on the back and then just a few extra actuators around the waist and on shoulders, we may choose a 6x6 grid. As shown here, a grid of 6x6 appears, and to make it even easier, we can see a gray background behind the 5x5 grid that we intend to place on the back. And then we can, of course, decide where the other 11 actuators will be placed, perhaps 4 of them on the shoulders and 7 around the waist. But what about more sophisticated haptograms that use multiple different body parts? We can also do that using the same tool. For example, by choosing a grid size of 8x12, which gives us the option to activate 96 different actuators. We may think that it would be difficult to keep track of which node corresponds to which actuator. Yes, that can be a problem. But we typically number the actuators that we use. And then here, we can use the option to show channel index, so we know exactly the relationship between these red dots and the different actuators that we are using. Looking at publications, it seems that many work with actuators for different purposes. And I guess that each one of them either uses a manual system to code and instruct the activation of actuators, or they each invent their own tool, reinventing the wheel without the rest of us being able to use them. This tool is, of course, very useful for us in SUITCEYES, but it can also be used by others in different settings, regardless of the actuator types they may be using. In fact, it does not even have to be actuators. It could be, for example, used to program a set of lamps to turn on and off in a predefined order. So I think that the different uses of our toolkit, which include the PCBs that was shown by Shandor earlier, and in this app together, they will be useful for many different purposes and scalable to many other areas. So this concludes our presentation. I stop here and we look forward to your questions and comments. Here are some contact information for the 4 of us involved in this session on haptogram design. I would also like to acknowledge contribution of a further colleague, Jonas Järvoll, in the development of our toolkit. Thank you for your attention, and please feel free to write your questions and comments, and we will try to respond to them as best we can. Thank you.
So we promised some technical issues and we delivered. If there are any questions or comments, I'm not sure. Shandor, are you available? Rita and Russ? I saw that some people appreciated your presentation, Rita and Russ. I haven't seen any questions. Shandor, are you with us? Would you like to add something to this?
Oh, actually, I am, but I'm not sure what to address here. I can see some kind of a question here. How can you make sure that others are persistent? But I'm not sure how to interpret this. Persistent in which respect? What we know is that at this point, falling short of user evaluation of the haptogram crit, it simply made no sense to increase the size of the vocabulary, but it could have been done. Ontology development covers now several hundreds of concepts and relations, as far as I know. Plus, Rita and Russ have been using in their own version of social haptic communication. My humble guess is thousands of signs. So in some sense, there's a lot to be covered in the future, and we could certainly do more. Okay, I can also add my video if needed. Yep, but the point is, right now, what we need is some opportunity to introduce user testing, to work with real life users with deafblindness so that they can guide us in the future what to do next, what not to do next. Of course, whatever we try to do with the kits introduced, both the haptogram design toolbox and the perceived ideas about the shapes of haptograms, they have to be supervised and constrained by psychophysical experimentation, because for now we have been mostly limited to the back of a user, and of course a lot more could have been experimented with different body parts with, again, different sensitivities. In this respect, the future holds many more opportunities. And another plethora of opportunities is that by the toolbox, different user communities and learning communities can tailor the available signs to their own needs or come up with their own designs. I stop here.
I see that Femke has got her hand up, and also maybe Rita has something to say. Do you have something to say, Rita, or?
Yep, it was Russ. Yeah.
Okay.
Okay.
I just want to point out that even though we initially started the social haptic communication, is not just us, it can be used by all deafblind people across the world.
It has been done already.
And it's already been doing this now for the last 20, 25 years, I think.
Mm.
So I think it's important people to realize that this isn't just our communication, this is an international communication platform.
With different language groups.
And it doesn't, you say.
Spoken or sign language users, yeah.
And also the different communication methods like deaf-blind alphabet, sign language, hands-on signing, spoken language. There's no definition between which groups you are. It can be used for a wider range of people, as I said earlier.
Yeah.
Femke, would you like to ask a question?
Yes, please. I think that the thing Russ pointed out, and he just said it, but also the one just before, that the one who is giving the sign, the signals, the haptic signals, need to be persistent. What I notice is that I can be a very tactile person because I'm deafblind, but those around me, which I need to communicate with me through haptics, often don't have a clue about the richness of tactile language and are not that very aware of how you can use tactile signs. So I think it's very important to include that in further research too. And I would love Russ and Rita to say something more about that.
So a very fast answer, please, Rita and Russ, because we are at the 45-minute mark.
Okay. Can I just add? Yep. Yeah, I just want to add in on that particular comment. I use this with interpreters, PAs, a wide range of family members and so on. So it depends on how much they understand and how much they have been trained to understand the whole social haptic philosophy. And I think that's the most important part, the training of those individuals need to also understand this. Yeah.
Great, thank you everyone. We are back to break and hopefully next session we start it a little bit better. Okay, see you in 15 minutes.